So hello everybody, I hope you can hear me. I'm Prasad Madhumagi. I'll be talking a little bit more about data types and while loops and functions. And at the end, we'll talk about a little bit of plotting functions like basic things in Python. Okay? And if you have questions like in person or online, in person, feel free to interrupt me anytime. And online, just post your questions. We'll get to you as soon as possible. So I want to start a little bit talking a little bit more about lists. Um, so you've all seen what list is and you know an arrays and how to convert go from list to array using NumPy, right? And list have this. You can do multiple. There are multiple operations you can do. Like you can convert arrays and add item to arrays, remove items. I'll just introduce like few more things, and after that you can. I mean, one nice thing about Python is if you don't know how to do something, you can just Google it and you can find it in like first or second result. So that's the nice thing about Python. So I'll just introduce you to like few things, and then you can find things your own or just ask us. We'll be able to help you. So, for example, if you want to add items to a list or remove items to a list, so adding an item, we use the command append. For example, I have this array or have this list with numbers 1, 2, and 5. And if I want to add add the number 4 to the list, right? I just do a dot append. My array is a, so a dot append 4. And if I print it, so you can see number 4 is appended or added at the end of the list, right? So it's appended. Right? So append means you add an item at the end of the list. And you might want to say add the item at an arbitrary location. You can do that, but we're not going like that deep. But it's a simple function. You can find it at you can add an item at any location. So also removing an item, you can use the remove function. So for example, I am removing the number 5 from the list, right? So this 5 is the actual item, not the location of the item. So I do a dot remove 5 and then I print it, and then I see 1, 2, and 4, not 5. And if I remove non-existing items, say if I remove 3, I'll get an error because it doesn't have the number 3. So, and if I remove number 1, I'll end up with 2 and 4 because I already removed number 5, right? If I declare the array again and remove number 1, I'll end up with 2, 5, and 4. So I think you get the idea. So you can do multiple useful operations like this with arrays and lists and like all sort of things. You can, yeah. So the next, okay. Do you have any questions? Nothing, right? So the next data type I want to talk about is sets. Set is a interesting data type. It looks like the list because it's a collection of items. So you can have multiple data types. You can have numbers, words, characters, Boolean types, or like anything, or it can, yeah. But there are few things that are unique to sets, right? Sets are unordered. I mean, for example, the list I showed you before, it has an order, right? 2 comes after 1 and 5 comes after 2. That's not going to change like when you print it again and again. But a set does not have this order. So if you print a set once, you will get you'll see the items, you might see the items jumbled, right? So set does not have an order. And the items are unique. So in a list, for example, we can put a, if I go back here, I can say 1, comma 1. I can have the number 1 twice and it will have no problem. But I can't do that with sets. Sets have unique items. One item can occur once, right? So for example, I have fruits, apples, oranges, pears, and if I print it, I get apples, oranges, pears. Oh, one more thing. A set is like you identify a set with curly brackets rather than square brackets like these, right? So if I put apples again, it will not print apples again. So I can't have a set with, apples twice. So if I can do like, say, green apples, that works, right? So items in a set should be unique, and in this case, they didn't print it in a different order, but it can. I'm sorry? No, you can have different types. You can have, say, number here. Right? You can have different types, right? But it has to be unique. That's it. I mean, you can put the same item twice, but it'll only show up once, right? So how do you create a set? Like I did here, that's one way. Also, you can convert a list to a set, right? It's easy. You can just use the set function. We'll get to functions later, but so you have a list, you have an array here, the same array I have had before, like apples, oranges, pears, whatever. And then I just use the function set and open brackets and close parentheses, So that's another way to declare a set, right? That's actually converting an array to a set. Right? There are some fun things that you can do with sets. For example, if you convert this string like 1, 2, 3, 4 to a set, right? And then now you can see 4, 1, 2, 3 because set has no definition of order, right? Numbers can or items can jumble up. So if you convert a string, right, into a set, it'll take the individual characters and create a new set with those characters, right? Yeah. Now I run it again, and now it's 4, 3, 1, 2. But if I have the same number twice, say like that, it's not going to take it. It's still the same character. So if you do RCC, which is us, you will get only C and R because C occurs twice. So this we can use to do different things. I'm not going to talk about the applications yet, but these are different things that you can use to do, what you want. So another example, like I have like 2, 2, 5, 7, 7. So you can find the unique elements like 2, 5, and 7, right? Before we move on to the next, anything, any question, any? Okay. So another data type is a dictionary. A dictionary is a key value pair. What's a key value pair? So a key is, like in a dictionary, you have like a word and the definition, right? So the word is the key and the definition is the value in this case. So the keys has to be unique. Like in a dictionary, the word itself are unique, right? The definitions, I mean, they are unique too, but there's no guarantee that two words might have the same meaning, right? In that case, the meaning should be same, right? So a dictionary is a key value pair. Keys has to be unique, but the values can be same or different. It doesn't dictate that. Python doesn't dictate that. So I have a simple example here, like capitals like Florida, Tallahassee. So the way you define or write a dictionary is you use the same as sets. You use curly brackets, right? And then uh, between the key and the value, you put a colon. So I think Marcelina covered this before. So you can break up the same line in Python into multiple lines. So that's what I've done here for clarity. If, instead of having a long line, right? So this is one value, like one key value pair. The key is Florida and the value is Tallahassee, right? And Georgia, Atlanta. So there's another, Georgia is the key and Atlanta is the value. So between the key value pairs, I have a comma separating them. Right? I mean, I can have this in the same line. Yeah. So it doesn't matter, but for clarity, we will break it up into lines. I don't have all the states here. It will be a long list or dictionary. So if you just print out the capitals dictionary, it will just print out the keys and values, key value pairs, right? So what can we do with this? So for example, if you want to find the capital of Florida, so you write it like this. So capitals and then the square bracket. Within square bracket, you have to enter the key, right? And if it's found, oh, what did I do? Oh yeah, I. I'm new to Mac, so bear with me. Yep, it spits out Tallahassee, right? But if I put something else here, if I put Georgia, oh yeah, of course. See, so if I put a key that does not exist, it gives me an error, right? Yeah. So you can find the value of that the key easily like this. I have an example here. The spelling alphabet. So it's very useful when you are talking to somebody over the phone. Say you want to spell your name, the last name. Especially I have a different name, so especially people say, "Hey, what's your name? How do you spell it?" I will say P, and they say so BRA. Then I have to say P for Peter or something like that. So this is very useful for me personally. So spelling alphabet. So that's a good example for why we use dictionaries. So A for alpha, like the key A, and alpha is the value, and B Bravo, C Charlie. So we separate them with the comma, right? The key value pairs, and we have all the letters. And you can break this line at any point. I just break it up in like 3 pairs, just that it looks nice on the screen. So I want if I want to have the word Python spelled out with the spelling alphabet, I need a for loop. Marcelina told you about for loops, right? I'm going to use a for loop. So I have the word Python in the variable word, right? So for a letter in word, right? So I use these variables. Okay, let me back up a little. So one nice feature of Python is it's like mostly English-like, right? So you can make it more looking English-like using this variable. So I use it for a letter in word, right? Print. Now D is my dictionary. This I define here, and the letter. before I do that, I'll just print the letter so that you see what's, because I know you are new to Python. Okay, so that's what the loop is getting, right? The characters separately, Python, right? And now I want to get the dictionary value uh, pertaining to each key, right? So what the P for what? Papa. So it's like that. So now I have to get the key value from the dictionary. So the dictionary name, and the square brackets. And when I run it, I get Papa, Yankee, Tango, Hotel, Oscar, November. So if you put anything here, anything else here, say Florida. Yep. So you see the point, right? So this is like a simple, fun example of what you can do with these basic data types of Python. Um, yeah. All right. So before we move on to while loops, anything for the data types? All right. So people, yeah, go ahead, Casey. Oh, letter is, that's a good question. The question is, what is the letter? Letter is an item. Okay. So letter is a variable. Okay. My variable name is letter, but I can put anything here, any variable name. So for this, I picked the variable name letter because it self-explains. So I can say L, not like that, but um, I can put L here, and inside the loop, I have to put L here, right? So it's anything, but I just put letter because it's more like easy to understand what I'm trying to do, right? So in this case, a letter is a variable. Right? You can have anything in there. It doesn't matter. So you've all seen for loops, right? And there's another basic loop type called while loops. Um, so I'll introduce the while loops a little bit. Okay, so there are two basic types of while loops: finite and infinite. So finite loops are the simplest type. So while loop is used when you want to run something with a condition, right? I think you've seen a condition before. It could be something simple as a number greater than or equal or less than or to another like value, right? So in this example, I set n to 1, n equals 1. So n is 1, and I write while n less than or equal to 5, right? So this condition, so my condition is n less than or equal to 5. So I'm telling Python I need a while loop, and my condition is variable n less than or equal to 5, and I put a colon to say that this is the beginning of my while loop. And then Jupyter Notebooks automatically detects it, and it does the indentation for me, right? And then I print n, and then what this does is it increments n by 1. This is just a fancy notation. I can write it like this: n plus 1, n equals n plus 1. It's the same as n plus equal 1. So if I run this, it will print the values 1, 2, 3, 4, 5. Because what happens is, so beginning of the loop, I set n to 1, right? And then it comes to the next line, and I say while n less than or equal to 5. Now the n's value is 1, right? So it goes inside the loop, and the next statement is print n, so it prints 1. And then the next line, the last line, n equals n plus 1. So n is now 1. So plus 1 is 2. Now n becomes 2. And then it goes up here, goes the while loop, right? And it checks whether n is less than or equal to 5. And it is, so it's 2. It prints number 2 here. And then it increments n by 1 again, and so on. And then finally, when n reaches the value 5 here, right? So it prints 5, and then it comes here, and n plus 1 is 6, and it goes to the while loop and see if the condition is satisfied. And now n is 6. So 6 is not less than or equal to 5, so it stops. There's an optional else condition you can have with while loops, but I will not go there. You can look it up if you like. I can say after loop is done, you can, if you want, you can make it do something, but that's an optional argument. This is the basic simple while loop. You know. Anything about the that while loop? Sorry. So the next type of while loops are the infinite loop with a break condition. So um, while loops are used when you are iterating over. Right. Okay. While I'm trying to simplify what I'm saying. So if you know how many times you have to run your loop, you use a for loop. Okay. Because for loop is usually, I mean, you can change it, but usually for loop, before the for loop starts, you know how many times it needs to run, right? Or the Python knows, because it might depend on the file you load, might depend on the values, the input values or something. But the point is, before you you start the for loop, it knows how many times it should be run. But if you don't, right, then you might want to use a while loop, because a while loop, you don't have to know how many times it's going to run, because it can determine pre-loop or inside the loop. So the infinite loop is a good example of a loop that doesn't know how many times it will run until it's run, right? So in this case, I run the loop with, while true. So here's my condition. My condition is always true. That means this loop is never going to end unless I stop it somehow, right? So I set two values here because I want to, do something like, so I set x to 10.25 and I to 0 in this case. And I say while true. Okay, so that's the beginning of my while loop. And here I do x minus equal. That's same as x equals x minus 1. Python is case sensitive, so I can't do lowercase. I can mix lowercase and uppercase. And I increment the value of I here. I'll leave it like this because I explained earlier. So I plus equals 1 means I equals I plus 1. And I have a condition here saying that if x is less than or equal to 0, break. Break means get out of the loop. Okay, that's how I stop this loop. So depending on the value of the x, excuse me, this loop will run like however many times it needs. And then at the end, I print I. I mean, so it's 11. So what happens is, so beginning of the loop, so x is 10.25, and I subtract 1, so it's 9.25, and I becomes 1, and it checks here, whether x is less than or equal to 0, and it's still 9.25, and so this condition, it doesn't break the loop, and it goes on and on and on until x is what? Okay, when x is say 0.25, right? So it comes here and it subtracts 1. So you get minus 0.75. So now x is negative, right? I is something, I don't know, maybe, I think I should be 11 by then in this example. And now x is less than or equal to 0. So this condition is true. So it executes this statement, break. So break means you get out of the loop. That's how I stop my loop. Uh, so although this is an infinite loop, I stop the loop with the break statement. So, and I print I get the value of 11. So this is like okay, this is not a practical example, but this I wanted to show why we use while loops when we already have for loops. Right. Yep.
Like traditionally, do they put print statements in between those so you can see each thing getting printed like in an infinite loop?
Okay, so the question is traditionally, do we put print statements in between, right? The statements.
You can see them like you see 1 through 11.
Yes. In this case, I put the print. Oh, you want to put a print statement?
I'm just saying like.
Oh yeah.
Is that like a?
We can. So yeah, that'll. I'll put a smaller value here, like 4.25, so that we get a smaller. In, I can print x, right? If I did that, you can see what's happening, right? Yeah. So you can see the after first during the first execution it's like it's 3.25 and what goes down and finally it's negative 0.75 and that's when the loop stops, right? And that took 5 iterations or 5 cycles, so 5 times the loop ran 5 times. Does that make sense to everybody? Okay. Yep.
To answer your question though, it's typically not done. So typically print statements are added into a loop to debug and test. But if you're given like a very large
Yeah.
like set of data, then when you print it, it's gonna take a lot longer for your process to run if you're printing every single number. So that's why sometimes you don't see it and sometimes you do.
Yeah, it's easier to like see how it works, and if you made a mistake to put a print statement, that's the first most basic way to debug something, like to see if you made an error. That's why I put it like a 4.25 here rather than the 10.25, because I'll get like 10 numbers listed here, and it's like so yeah. So this is just a example of explaining things. So that's why we put print statement, but you can do operations without the print statement like before. Yeah. So I have another example, like while loop example. Um, because at the beginning I talked about the append uh, operation to a list, right? So I defined my list. So I define an empty list. So that's how I define an empty list, right? I just put a square bracket open and close. So now Python knows that my list is a list, okay? And I set x to 10, and my condition is while x is greater than 1. Okay? As long as x is more than 1, my while loops run. So is this a finite or infinite while loop? What do you guys think? Is it finite or infinite? Um, it's finite because I have this condition, right? Because it's not like this. This is my infinite while loop. It's always true in this case. No matter what, I have the Boolean value true here. So it's 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 true no matter what. But here it's only true if the value of x is greater than 1, right? And then I do my list dot append x. So I append the value of x to my list, and So now how many elements? Okay, so at the beginning, how many elements does my list have? None, right? But when the loop runs the first pass, it'll have one element, right? Because it adds the value of 10 here. And then I just do something. So I divide x by 2. So you can do it like this, like in the short form, x equals, no, x, yeah, divide equals to, yeah. So so I have 10, 5, 2.5, 1.25 because the next fast is half of 1.25 is like less than 1. So this loop breaks in that case. So if x is less than 1, then the loop stops, right? So now the array has values 10, 5, 2.5, and 1.25. And if I run this again, I'll have the same, right? But if I comment this, if I don't declare the array again or the list again, right? It's going to do what? Right? It's going to append those numbers again to this list because I didn't redeclare the list and it already exists and it just appends items to that existing list. If I run it again, it will be a even longer one, right? So the point is you have to be careful when you are appending elements to a list, whether you want to like delete the list or like redeclare list in that case, or if you keep using the same list, then you might, end up with undesirable results, But if I do that, I'll always get the same result. Okay? So any questions about the loops or the sets or like any things we've done so far? Um, what time do we give the lunch break? Yeah. Okay. Right. So next section is functions. Why do we use functions? Okay. So the easiest example is, okay, suppose you want to write a long code, right? And say you have to, hey, for example, you want to ask for like details of a person, right? So you ask the name, age, occupation, or whatever details, and then you put it in a list, right? So you'll be like asking the question, getting the value, putting it in the array, asking the question, getting the value, putting it in the array. So you are doing repetitive tasks, like same thing over and over again. Or if you're doing a calculation, you might want to do the same calculation over and over again. So you are writing the same few lines several times in your code. So your code is getting longer, but you're just copy and pasting the same lines with smaller changes, right? So one thing to avoid that is use function. You take those lines that you want to use over and over again, and then you declare it as a function. For example, hey, I have a simple function here. All right. One more thing about functions. There are two types of functions. The functions I just told you about, right? The custom defined functions and the built-in functions. Built-in functions are the things that we already saw, like type conversion or the set function I used earlier to convert the set a list into a set, right? Those are built-in functions. The math functions, sine, cosine, integer, whatever. So those are all. Even the append is a function or method, right? So these are built-ins. So you can define like custom defined functions. So I define this simple function called my function first. So the way you define a function in Python is you start with the word def, def. So then Python knows that, Okay, so you are defining a function. After def, you give the function name. I give my function, and then within parentheses, you have to say what variables it takes. A function can take one or more variables, but it doesn't have to. You can have functions takes no variables. Mm, yep. Yep. So you can have functions taking one or none. I mean, none or more variables, like no variables or any number of variables. In this case, I take one variable, right? And I say if x is greater than 0, return positive. So the function, if you define a function, you want it to do something, right? So it can return a value. We'll see what this exactly do in a second, but return is the outcome of the function, right? So you write a function and the outcome is defined from this word return. So def is a keyword, return is a keyword uh, that are unique to functions. So in this case, I return the string positive, right? If x is greater than 0, I say positive, and else if x is negative, I return the word negative, and otherwise I say 0 because that's the other case, right? If it's not positive, not negative, then it's 0, right? So, and then this is how you like use the function. So now you define the function and then you call it with name, right? I gave it the name my function. So I call like my function in parentheses, I put 1, right? And then it should say positive. And if I put say -1, it should say negative, and then if I put like uh, if I put 0, it should say 0, right? I mean, I don't do any type checking here, so if I put a word, I should get an error, right? So it doesn't know what to do because I didn't declare in the function how to deal with letters, right? It only knows how to deal with numbers. So in general, if you are defining a function, and you should be careful to what could be the input, right? Or like when you use the function, you have to be careful that it only gets the desired values, right? Otherwise, you will get an error, and you have to deal with that. So this is the easiest or simplest form of a function, but right, you can have, like I said, multiple values as an input, right? So in this case, I define the function f, the QTY, the quantity, item, and price, right? So I calculate the total price as equal to the quantity times price, and then I print, uh, okay, in a fancy way, I print the quantity, item, cost, right? And if I run this, so now I have to enter 3 values to this function, right? Remember, when you use the function, you don't talk about these variable names. That means the order of the items that goes into the function are important. So in this case, I put say 2, quantity 2, item name apples, and the price is 2.5. And my fancy output says 2 apples cost $5, right? But if I change the order, will this work? No, because if I put apples first and 2 second and 2.5 after, it will not work because then it will have a string. We can do it just to see what happens. Then you'll get an error. Yep. it doesn't know how to multiply, you know, I have I have the quantity as an apples, so it can't multiply the word string apples with price with a number. So the order is important, right? When you define a multivariable function. So this fancy output, I'm going to skip it for now. Um, it's a print command. Uh, we can discuss about this later. Uh, Basically, it's printing the quantity as a number and the item and the cost, and then with the dollar sign, you print the price. Right? So my point is, when you define a multivariable function, the order of the inputs is important. So you can have, okay, any questions so far, online or in person? Yep. Okay. So I have this optional arguments to a function. So optional arguments is, okay. So I define this function workdays, right? And I define this optional arguments with holidays equal to Saturday and Sunday. And inside the function, I define the days as, weeks of the day. And then I say, for the day in days, like if it's not in holidays, I print the day, right? So the point is, my optional argument is here is named holidays, right? If I call this function without this optional argument defined, without any value, it will still work. It'll tell me the work days, Monday to Friday, right? Because my optional argument is holidays and it's already defined here, right? In the line I define the function name. So it doesn't, you don't have to give the input value. But if I have other days as holiday, I say Monday is a holiday, then I redefine the holidays variable like this. So I say Saturday, Sunday, and Monday are holidays. And then it'll say, okay, work days are Tuesday, Wednesday, Thursday, Friday. So this is how you use function and have an optional argument. So you don't have to define holidays because it's already defined in the functional definition line. Okay? Otherwise, you have to define, a value. Otherwise, Python doesn't know how to handle it, right? So the last form of function I want to show you is passing variable number of arguments. So if you don't know how many variables you are going to, pass, what can you do? You can either use a list or you can use this star variable. You can put a star and put the variable name. Args is just an arbitrary name. And in this case, I'm just going to add all the numbers and get the sum, get the total, right? So I have a for loop for saying for arg in args, total plus equals arg and return the total, right? Pretty simple for loop, right? So I give like 3 values to the total function and it calculates the value, and I give 2 values, 2 integers, and it calculates the value as a float because the addition operation gives you 10, right? So that's how you use this optional like variable number of arguments. That's the first part of my talk. We have I have some hands-on activities prepared for you, but we are running out of having time issues. So how are we going to proceed? Like, hi again. So we'll go through this plotting section. It's a short section. We just didn't have time before the lunch. So one of the most interesting thing with Python is unlike say C++ or Fortran or C, it's very easy to, plot data and make like, nice looking plots or publication quality plots if you're interested. And it's all done with this module called matplotlib. It's already installed in your, if you're logging in, if you're using Open on Demand, it's already installed in your environment. You can just import it like this, import matplotlib. It's same as NumPy, it's similar add-on modules, right? So we import matplotlib.pyplot as PLT. Uh, this the PLT is just a handle that we don't want to type like the whole matplotlib.pyplot every time we use it. So in this case, I'm just creating some data. So x equals range 0 to 10. So I get numbers from 0 to 9 as my x-axis, and my y-axis is numbers from 2 to 11. And I just do like plt.plot x comma y, right? And that generates the plot. But to see the plot, you have to do plt.show. So show is a built-in function in the library, and that will display the plot you just made. Okay? And you can see the axis, there are no labels in the axis, but the axes are like numbered and everything. And the colors are all default colors. The line color is a default color. You can control all that. Matplotlib, if you go to Matplotlib web page, you can see all the options, customizations. You can create a title for the plot and two labels. I'm going to show a little bit of that in the next example. The next one is I just wanted to do like scatter plot, like just the dots, not the line, right? So this is little bit complicated because I'm creating random data rather than just creating numbers from 1 to 10 or like before. So for that I use NumPy. So I didn't run the. Yeah. So for that I use NumPy. So NumPy can generate random numbers in like whichever distribution. So this is just a simple normal distribution. So I generate x and y, the positions, and then just so that it looks interesting, I'm going to vary the size of each dot, each point, and the color, right, randomly. So I generate that as well, the sizes and the colors, right? This len function refers to the size of the x, right? So that's, x is an array, right? So len function gives you the length of this array. So how many elements are in there, right? So I need to create the same number of like sizes and colors to go with. And then the actual command is, plt.scatter. It's a scatter plot, not a line plot, right? X comma y and s equals sizes. So s is an optional variable to this scatter function, right? So we generated sizes. So s equals sizes, and colors we already generated here. So we provide all that. And now I'm going to label my x-axis as, guess what, x-axis, and the y-axis as, y-axis. And then I'm going to generate the plot. You might get a different plot because I'm using random numbers, right? So every time I run this, you get different plots. But, these are like nice looking plots. We didn't do much work, right? The plotting itself is just this one line, this line, and then the axis labels and the showing plot. So plotting itself is just 4 lines and displaying. And you can have the labels like graph label and all that set up. You can do much more things, but I'm just going to show one last example of like a bar plot. Um, so just like before, I am generating X and Y data random, and then the command or the function is plt.bar. So the bar is the command to generate a bar plot, and then you have to specify the width of each bar, right? I just set it to 1. I mean, we can change it. And this is another optional variable, edge color, like what color each bar is uh, drawn with. If I run it, you'll see a different graph because it's all random. Yeah. Like before, I can like name the axis and name the graph and do everything. So there's just a lot of things you can do with Matplotlib library, like generating different kind of graphs, but these are all static, not interactive. Python can also do interactive graphs, but we'll show that in the next section. We have an example to show you an interactive graph, how to generate it. Any questions so far?
How do you export one of those pictures? You want to publish it in a paper?
Yes, it's plt.savefig.
You want to repeat the question for it?
Yeah. Oops, sorry. So the question is how to save these graphs, right? So it's plt.save, I believe. Oh, save. Oops. And I have to give savefig. Yep. And I have to give the file name. I think usually I guess what Google the command before I do it, but yeah, it worked. So that's how you save it to like use it somewhere else. Any other question online? Yeah.